Sure, yeah. Hello, everyone. Thank you for joining us today. My name is Boris. I am from the ecosystem team at Aligned, and it is my pleasure to be doing this fireside chat with Mauro, our head of engineering and co-founder. And hopefully we'll get to teach you a little bit about Aligned. Hopefully we'll have some time for questions at the end as well. So without further ado, Mauro, welcome.
Thank you for the presentation, Boris.
Thanks. So I guess let's get started. Maybe just some background on you, like how you got to this spot, engineering background. Yeah.
Yes, I have been doing cryptographic engineering in Lambda class before founding Align with Hershey, Diego, and Fede. So while I worked there, we noticed many problems and things that happens with CK that we wanted to fix, that we thought that we were going to be able to fix. Part of that experience led to Align now.
Very cool, yeah, which actually may be a natural transition to my first question, which is, what is Aligned?
So Align is a verification layer for CK proofs. The idea is to provide some primitives or some way to cheaply verify any kind of proofs and have the results in Ethereum. This allows a lot of applications. Many of the applications have been mentioned before in the previous talk. But usually, if you want to put proofs in Ethereum, you need to reach some acceptable cost. You need to wrap it on Groth 16 or do some kind of tricks that adds latency for the users, and they make a really bad experience. So maybe...
Yeah, I mean, that brings up a lot of things that I want to ask you about. Like, even just at a super high level, like why do you care so much, or why do we care so much about making ZK accessible and useful on Ethereum?
Yes, there are, as I said, many applications. I can tell a couple ones. So this started, for example, discussing with another team in Lambda that was doing a bridge for Mina. Mina uses some variant of Halo 2 proofs using API. So if you want to make a bridge to Ethereum, what you need to do is verify those proofs in Ethereum. It's just that. If you are able to do that, you are fine. But if you try to do that, that will take you around 20 million of gas. So good luck paying for that. It's too expensive. So interoperability between chains that are not related to Ethereum with CK chains is extremely difficult. That's, for example, one application of Align. We can verify that kind of proofs for almost no cost.
Yeah, very cool. Yeah, so for people who don't know, Mina is an L1 ZK blockchain. And we actually just announced partnership last week. So there's going to be a bridge between Mina and Ethereum that is using Align to verify its proofs. Yeah, so I mean, this is a great example of why we need fast and cheap ZK proof verification. It's to enable things like bridges between blockchains, roll-ups. We can talk about possible use cases and ideas later, because we have a whole bunch in our docs. If anyone wants to take a look, we'll have a QR code later. But I'm thinking maybe what could be useful is to actually just go through generally how Aligned works. Like, maybe clear up some misconceptions. We're not a blockchain, for example.
That's a good one. Sometimes people come and ask us, well, are you a blockchain? Well, we don't have a block, we don't have blocks, we don't have a chain. We don't have the concept of order, so we don't have a sequencer, for example. We are clearly not a blockchain. We cannot compete with Ethereum, in fact, because we are missing most of the things. We are just an extension of Ethereum to do some really small thing that is the verification of proofs. And we do this by leveraging EigenLayer, so to build like a network of verifiers using risk-taking, validating all the proofs, and then submitting the results to Ethereum. At least that's one of the most innovative way we work, that we call like the fast mode. The other mode is an aggregation mode. I think I won't be talking about aggregation. You probably know that about, because there are many projects doing that. So we can focus on the fast mode or any other questions.
Yeah, let's hear about the fast mode and the kind of throughput that we can offer using Aligned.
Yeah, so Since we are just running native verifiers, it's really easy to add new logic to the layer. So we can run any verifier. Right now we support RIS0, SP1, many of the NARC verifiers, Halo 2. We are finishing the integration of Scholt, that is an RCK VM, and Circom. So we support many verifiers, and every time that the tech moves a step forward, maybe the next new proving system is going to be Venus, for example. I don't know, Venus is really good. So if a new prover comes that is really fast, we can just plug it in and use it on the network.
Cool. Yeah, so why not just verify these proofs directly in Ethereum on the EVM is a question that some people might have, and that I definitely had when I was learning about this.
Yes, so sometimes you can't, as I said before, like to have a decent price for a proof in Ethereum, you need to use a specific proving systems, like for example, gross systems. They are not that cheap either. Like we are cheaper than a native verification of that kind of proving system. But others you cannot. Like the API proofs of Mina is 20 million gas. Venus, I have not seen any verifier, and sometimes you can, but you add a lot of latency. If you are using SP1, for example, and you want to wrap your proofs, it's okay, you can do that, but you are going to add many minutes of delay to your program. So if a user is interacting, I don't know, with a phone and wants to do something with Ethereum, it's going to be really bad from the point of view of usability. It's better to just generate the proof with the fastest proving system that you have, in the fastest way possible, and send it.
Yeah. So once the proof gets sent to Aligned, what happens to the proof? Like, how are we verifying those proofs that get sent to us?
So yeah, the architecture works. We have like a batching system that is going to merge your proof with other ones in a big task. So, and that task is going to be created in Ethereum with the proofs being available in some that data service. Then our network of operators downloads the proofs, runs the verification of each of them, and signs the batch. It says, okay, this batch of proofs is correct. Or if he finds a mistake, it doesn't sign it. And then it answers to another entity that we call the aggregator. It's an aggregator of signatures. So all the results get sent there, and if there is no quorum, usually 2/3 of it, then we say, okay, this proof is okay, and it gets sent to Ethereum.
Okay, cool. So now the proofs have been sent to Ethereum. How can a different user use these proofs and like the fact that they've been verified correctly?
Yeah, so to use in your own smart contract, Align is really easy. When you interact with the batcher, you receive a package of data that, well, it includes a Merkle tree, some commitments. I don't want to go too deep, but you receive it. And then you can do a static call to our contract and ask if your specific proof is in the batch. The user needs to be sure to enforce that the proof is from a specific circuit or a specific RIS program that he's using, but that's it. It's very simple. We have some example applications in documentation, some CK quiz using Rust provers that gives you an NFT and others. You are free to check them out and think more applications.
Yeah, I mean, I definitely want to ask you about potential use cases and things that can be built using Aligned. And we could probably talk about this for hours. But maybe I'd love to hear your top 3 or 3 that you're personally excited about. We do have a bunch in our docs, but we have a chance to ask Mauro what he's excited about. So.
Yes, well, interoperability is a really great example. I think that will enable the communication with a lot of blockchains, even blockchains that are totally not related to Ethereum, that might have some privacy properties like Mina. That's awesome. And at the end, it's like you can do whatever you want. Think that it works. You can call any Rust code that you have, do a lot of computation, run machine learning models, run a game, run whatever you want, then send the proof to Ethereum, and have the result there, like for really cheap. If you can offload any computation, you could probably even offload a computation that you will usually do in Ethereum and just send it to a line and get the result there. And let me say another thing that I didn't say before. It's not just that it's cheap, but it's really fast. We can send a proof every block if we want a batch every block. Right now, if you use the testnet, the latency is 2 blocks. So you send something, you wait 2 blocks, and the results are there, ready for using.
How many proofs can we get into a block?
So we are doing 2,500 proofs per second. So usually the blockchain collapse before us. So not in the sense that we cannot send the proof, but let's think that the cheapest thing that you can do in Ethereum is a transfer. That costs 21K of gas. So you can do around 1,000 transfers per block. So if using a proof will be just doing one transfer, you could use 1,000. So it will collapse. In fact, we are going to add some solutions. It's not going to be just the right thing that we are going to solve, but we are going to solve the fact that even 21K gas is too much. But yes, 2,500 proofs per second, that was the most that we have pushed the network. I think it can probably do more. In a batch, we have done around 100,000 per batch. You can.
Wow. That's super cool. Well, you mentioned the testnet, so I'm wondering if you can talk a little bit about the stage of what's out there, what we've released so far, what people can do right now to interact with the testnet, play around with it.
So yeah, if you want to just try it really fast, you can run 2 commands that are on the documentation, and you will be sending a proof to a line, and you will be able to see that it has been verified in the Explorer and follow the link to Holesky. All the testnet is deployed in Holesky, and you can try it by yourself. You can also start building applications. That's going to take a bit more of time because you will need to create some code or create your own contract that does something with a line. But it's not too complicated, so you can do it and start experimenting. You can use the testnet without paying, so if you don't want to be dealing with that right now, it's okay. And if you want to test the payment system, you can also pay it with Ethereum in Holesky and see how it goes.
What about running the actual AVS as an operator?
Yes, so right now the operators are whitelisted by us. In mainnet, the idea is probably to have the ones with more stake running and set a fixed amount of operators. So yeah, the network is not open for operators, but it is open for using and creating applications. If you want to run an operator, you should contact the team and discuss that.
Yes, please reach out. Well, you mentioned payments, and I know we can talk about this for a long time, but I did want to ask about cost, right? We've talked about how it's much, much, much cheaper to verify proofs this way than directly on Ethereum, but how much are we talking? If you have some back-of-the-envelope calculations or examples. Yes,
so right now the system is running a bit more expensive than I would like, so it's 400,000 gas. So that's probably almost a gross 16 proof. It's almost the same. But that gets divided by n, so by all the users. So in the case of the batch of 100,000 proofs, I don't know, that's probably less than 1 of gas per user. I don't want to say that's going to be the final price. There will surely be some need to pay for the stakers or for the system running. But you can imagine that the costs are going to be extremely low because they are almost non-existent. Then the risk should be around 40K, but it's also going to be reduced. We are expecting to bring down to 3K.
So yeah, basically by having more proofs put into one batch, we amortize the cost over the number of proofs and bring that down dramatically, right?
Exactly, that's right.
Yeah. So the more proofs you send, the cheaper it gets. So if you have proofs to send, please send them over.
We love having proofs in our systems.
Okay, let's see. I think we covered a lot of the most important things. I will maybe take a second and see if there's anyone in the audience that has questions, since this is kind of like a more casual fireside chat.
Thank you. So if it's so much smarter, better to send like a bunch of proofs, would I have to organize that, or can I kind of collaborate with other parties to like get lower costs because you're gonna do much more proofs but batched?
That's a good question. So yes, you don't have to organize with others. What we provide is a service of batching that you send your proofs to the service, and that service is going to share your proofs with others. And that's it. If you still want, for some reason, to send your proof by your own because you really, really want, and you don't care paying because maybe it's still cheaper than other alternatives, you can also do that. But you don't need to.
All right. Does anyone have any other questions? Are you guys good?
Okay.
I can ask a couple more. Yeah, I guess, let's see. What kind of timeline are we looking at? Like, when will all of this be live? Do we have some idea of this for like mainnet applications?
Yes. So the testnet is pretty much complete. So what we are doing now is reducing some trust assumptions of the payment system. That should take around 2 weeks, maybe 3 weeks. We will see. And then the audits. Like, the main delay for this is that we want really good audits. We don't want something bad to happen. So that needs some time to review the whole security of the protocols. But everything should be in this quarter, basically.
These guys are shipping. Mauro is leading our engineering team, and they are working super hard. So people can use ZK as soon as possible for all sorts of things. One last question, because this is something I'm actually personally curious about, and it is the eigenlayer side of things, because we're Ethereum aligned, that's part of the name, and we're borrowing economic security for the proper verification of proofs through eigenlayer, restaked ETH. How, I don't know if we can talk about this, how secure is this, for example?
Okay, yes. So it is economical security, what we use in fast mode. When the proof ends up in the blockchain through aggregation mode, it's going to be all the security of Ethereum. But at the end, the security of Ethereum is also economical security. It shows a very high economical security. And we are aiming for more restake value than L1s. So it should be more secure than, in terms of economic security, than most of L1s except Ethereum. Ethereum is the biggest one, of course. So yeah, for most applications, let's say that you have 1 billion of economical security in stake. If you are just going to be sending some money in every dish, it's okay for most applications.
So yeah, as long as you're not sending $1 billion.
Yeah, as long as you're not saying
okay.
$1 billion. If not, in that case, even I would suggest use another thing. But if it is 100,000, 1 million, a couple of millions, not 1 billion, but you should be able to use it.
Very cool. All right, so Mauro, thank you very much. Everyone, we have a lot more information on our website. You can follow our Twitter to keep updated. We have documentation, ways to contact us. We'll be hanging out for a bit if you have questions and want to chat. So once again, Mauro, thank you very much, and thanks for listening.